I'd like to demonstrate the process of using storage XenMotion in CloudStack version 4.10 along with the SolidFire storage plugin. Now, to be clear, version 4.10 of CloudStack has not yet been released. As I record this today, it's August 23rd, 2016. Version 4.10 is probably to be released in a couple months. Okay, so for an overview of the environment I have here, I have a single zone, single pod, 2 Zen server clusters, 3 hosts in those clusters, 2 in the one in the other. They're all running version 6.5. And for primary storage, I'll click on the View All button. We can see right here I have a few of them, but the one of most interest to us for the purpose of this demonstration is the one that I just highlighted, the bottom row in the table. Now, this kind of primary storage is unique in a couple ways. Number one, its scope is at the zone level. And number two, for every virtual disk that you have an equivalent, or I guess a peer, SolidFire volume on the SolidFire cluster. So for example, you spin up a virtual machine, its root disk requires storage somewhere. We create a SolidFire volume based on the size of the virtual disk and taking some other parameters into consideration. And on top of that SolidFire volume, we apply a storage repository and then stick a virtual disk within it that represents the root disk of your virtual machine. Now, on the SolidFire system, volumes have guaranteed performance. So on a volume by volume basis, you can control performance. And since you have a single virtual disk on each of your SolidFire volumes, you have guaranteed performance on a virtual disk by virtual disk basis. So for example, you could have a root disk with a smaller amount of performance than a data disk, and they're both controlled with the same virtual machine. So at this point, I'm going to go ahead and demonstrate how to create a compute offering and also a disk offering that makes use of this particular kind of primary storage. Okay, let's switch over to the Service Offerings tab. And in the upper right, I'll click on the Add Compute Offering button. And let's put a name in, maybe SFC01 for SolidFire Compute Offering 1. And for the description, I might do something along the lines of indicating how much performance is to be expected for this particular virtual disk. I should say in this particular case, for the root disk of a VM that's spun up using this compute offering. So let's say 1,000 4K min IOPS, and let's go with 2,000 4K max IOPS. And we'll actually enforce those in a bit by filling in the appropriate fields. Before we do that, let's provide information like the number of CPU cores, the megahertz rating, and the amount of memory that we like. I'm going to scroll down a bit here. And now we've gotten to the quality of service area. So I've clicked on that combo box, and we can see there's a few options. One is blank, basically do nothing. 2 is related to hypervisor rate limiting for the KVM hypervisor. And the one that we're really interested in here is the one for storage quality of service. Once I click on storage in the combo box here, we'll see a few more fields be displayed in the dialog. So here I go, I'll click on storage, and we can see now that we have a few more fields. We have custom IOPS, which I'll get to in a moment. We have the minimum IOPS, which I'll go ahead and fill in what we put in our description, which was 1,000 minimum and 2,000 maximum. Now here, as an administrator creating this compute offering, I can either fill these numbers in, or maybe I'd prefer to pass this option on to my end user. And the way I could do that is by checking the Custom IOPS checkbox. That way the min and the max IOPS disappear, and when someone is looking to spin up a virtual machine that makes use of this compute offering, then they can provide the minimum and the maximum IOPS. Now, a lot of times in a public cloud environment, that's not a very popular option, but in private clouds, that can typically be commonly leveraged. I'm going to uncheck it though and be consistent with what I wrote in the description and have specified 1,000 and 2,000 for the min and max IOPS respectively. For the hypervisor snapshot reserve, this will actually help us decide how large to make the SolidFire volume. So let's say our virtual disk is 20 gigabytes. If I put in 100% for the hypervisor snapshot reserve, that means our SolidFire volume should be the 20 gigabytes for the virtual disk plus 100% of that 20 gigabytes on top of it. So 20 gigabytes plus 20 gigabytes, we would expect the SolidFire volume to be 40 gigabytes. And there's several reasons that you might make the SolidFire volume larger than the virtual disk. One is because on top of the SolidFire volume, a storage repository is applied. So with iSCSI, it's LVM, and with other storage repository types, you can do different things. But in our case, you're going to have LVM on top of the SolidFire volume. And so that requires space in and of itself within the SolidFire volume. And then you get around to needing space for the actual virtual disk. Now, if you do things like take hypervisor snapshots, you'll need additional space within that storage repository. Or if you do things like we're going to do in this video, where we use storage XenMotion, you actually need a little more than 2 times the size of the virtual disk in order to make that storage XenMotion successful. So they store additional data on the storage repository while they're in the process of copying the data from the source storage repository to the destination storage repository. And so to make this successful, we need that SolidFire volume to be a little more than 2 times the size of the virtual disk. So in our case, let's specify 125%. So if our virtual root disk is 20 gigabytes, this will give us another 25 gigabytes on top of that. So we should expect to see the SolidFire volume at around 45 gigabytes. And that will allow us space to have successful storage XenMotions. Now here we'll pick storage, a storage tag that is referenced in our primary storage that's backed by the SolidFire storage plugin. No other of my primary storages make use of this particular storage tag. So we know when we spin up a virtual machine making use of this compute offering, it will need to use the primary storage that's based on the SolidFire storage plugin. And at this point, we're all set. We can just go ahead and scroll down to the bottom and hit the OK button. In a moment, we'll see we have a new compute offering. There we are. Okay, while we're at it, let's go ahead and create a disk offering. I'll go over to the Select Offering combo box, drop that down, and select Disk Offerings. In the upper right, I'll click on the Add Disk Offering button, and I'll put a name in like SolidFire Disk Offering 1, and a description, SolidFire Disk Offering 1, and then similarly to what we did with the compute offering, I'm just going to stick in the number of IOPS. So 3,000 minimum, 4,000 maximum. Let's make the disk size 100 gigabytes. And for the QoS type, we'll drop that down and again select storage, and we'll see our fields again. I will put in the 3,000 minimum IOPS and the 4,000 maximum IOPS. And then just like we did for the compute offering, I'm going to stick in 125% for the hypervisor snapshot reserve. Now we can go down to the storage tags area, and we'll make sure we put in the same storage tag that we had for our compute offering, because in a moment I'll spin up a virtual machine, and I will also have that virtual machine have a data disk. And we'll make sure in this particular demonstration that they're both placed on the same zone-wide primary storage that's backed by the SolidFire storage plugin. So this is all we need to fill in here. I'll just go ahead and hit the OK button. In a moment, we'll see we have a new disk offering. There we are. Now that we have a disk offering and a compute offering, let's go over to the Instances tab and spin up a new VM. In the upper right, I'm going to click on the Add Instance button. We will create this VM based on a template. I just have a single Xen server template at the moment, so we'll leave that selected and click the Next button. I'll click on the SFC01 compute offering and hit the Next button. I'm going to go ahead and click on the SFD01 disk offering, so not only will we have the expected root disk, but we will also have a data disk. Then I'll go ahead and click the Next button through the Affinity Network and SSH screens and come to the Review section where I'll put in a name. Let's go with VM XS-1 and I'll hit the Launch VM button. At this point, CloudStack is running through its orchestration logic. It sees that the virtual machine is supposed to use the template SFC01, that's our compute offering that we created. And specifically with regards to storage, it sees that the storage tags field has a storage tag that can only be satisfied by one of the three primary storages that I have in this environment. And that is our zone-wide primary storage that's based on the SolidFire storage plugin. Once CloudStack discovers that the SolidFire storage plugin supports that particular primary storage, it starts invoking functionality on the plugin such as create volume. Now let's go ahead and take a look at the SolidFire GUI. I'll switch over to that tab. And I'm on the Volumes tab already. I'll go ahead and click on the Refresh button. And we can see here the template that I selected for this virtual machine was not yet stored on this primary storage. So right now what's going on is we're copying it down from secondary storage to a new SolidFire volume. And once that's in place, we'll go ahead and clone that SolidFire volume, and the cloned volume will serve as the repository for the storage. It'll contain the storage repository as well as the virtual disk for our virtual machine. And so as we spin up subsequent virtual machines, in theory, with this particular template, all you would have to do at that point is clone the existing SolidFire volume and make use of that cloned volume for your new virtual machines. So the first time you copy down that template and then clone, and then subsequent times you just clone. Now let's go ahead and hit the refresh button again and see what kind of progress we've made. All right, so we can see here, and I'll highlight it, our SolidFire volume that contains the template that we copied down from secondary storage is now, I'll highlight it over here, no longer in a volume access group. A volume access group is a data structure on the SolidFire system that contains a list of volume IDs and then the iSCSI qualified names of the hosts that have the right to access those particular SolidFire volumes. So for example, and I'll highlight it here, The XS-cluster-1 volume access group has two IQNs in it. It's the iSCSI qualified name of each of our XenServer hosts in our first XenServer resource pool. And then the other has the one IQN of the one XenServer host that's in that other resource pool. Another way of taking a look at this information is to go over to the volume access groups area. And we can see here we do have two volume access groups, one for each of our XenServer resource pools. And as you'd expect, in the one we have two initiators, and in the other we have one initiator. So that's just kind of how that works in terms of mapping host IQNs to the SolidFire volumes that they have access to read-write from. Now let's switch back over to the Active Volumes tab. And we can see here, so we have our SolidFire volume that contains the template. It is no longer in a volume access group because we don't actually need to read or write from it from a XenServer host perspective. Now it remains on the SAN for the purposes of us cloning it as we need to. And we did need to clone it in order to create the other SolidFire volume here called root-24. And root-24 is, as we can see here, in a particular SolidFire account. So this is probably a good opportunity to mention that SolidFire has the concept of multi-tenancy very much like CloudStack. So for each of our CloudStack accounts that interacts with a SolidFire system, there will be a SolidFire account on that SolidFire cluster. So that's a very nice way of seeing who owns what from CloudStack's point of view on the SolidFire cluster. Now let's go back over to our XenServer environment. And we can see here, I'll highlight it, this particular virtual machine is still in the process of being spun up. We have our root disk, which is stored on the storage repository that I just highlighted, and this is beginning to finalize, and we'll see in a moment, and here it comes, I'll highlight it. We have a second storage repository, and this is going to be for our data disk. Now that will come and go a bit as things get finalized within CloudStack and its interaction with the XenServer cluster. But in the end, what we'll see here is we have a separate storage repository which has our virtual disk that's serving as our root disk for our virtual machine. And that storage repository contains just a single virtual disk. In fact, I'll go ahead and select the storage tab and we can see that. Here's our virtual disk that is our root disk. And if I click on the other storage repository, which looks like it's just finalized coming up, we can see if I switch over to its storage tab, it as well has just a single virtual disk in it. So each of these SRs contains only a single virtual disk, and each SR is associated with its own SolidFire volume with its own performance characteristics. So now we can see here, and I'll highlight it, our virtual machine is in the running state. If we switch over to the console view, we can see that it's booting up. And while this is booting up, let's switch over to the SolidFire GUI one more time here, and then go over to its Quality of Service tab and hit the refresh button. Now we can see here we've got a SolidFire volume called root-24, which has 1,000 4K min IOPS and 2,000 4K max IOPS. That maps onto the compute offering that we used to spin up the virtual machine. It said that the virtual disk should have 1,000 minimum IOPS and 2,000 maximum IOPS, and we can see here that that is in fact the case. Now our data disk, which I'll highlight the name, it came from a disk offering which specified 3,000 minimum IOPS, which we can see here highlighted, and 4,000 maximum IOPS, which I've just highlighted as well. So we can see that our performance characteristics are as expected. Our root disk has the right performance and our data disk has the right performance. And in fact, those performance levels are different from each other. Let's now switch back to the CloudStack GUI. And we can see here, if I click on the Instances tab, it'll refresh the information and include our IP address. So we're in really good shape here. I'll go ahead and click on the name of the virtual machine. And we can see scrolling down here, you have all of the information that you would expect, such as the compute offering that was used as the template for this virtual machine. And we can see what host the virtual machine is currently running on. If I switch over to Zen Center, we can see I've highlighted the virtual machine, and if I highlight above, we can see that we are in fact on Zen Server 6.5-3. So that all looks really good. Now let's say that we want to move this virtual machine to the other Zen Server cluster. I'll go ahead and highlight the resource pool that I'm referring to. We can do that very easily now. I'll switch back over to the CloudStack GUI by simply selecting the Migrate Instance to Another Host button. And we can see in the drop-down list here, there's a couple options. Now we know there's 2 Zen Server hosts in that other resource pool, and they both show up here. I'm going to go ahead and pick, I guess I'll just leave the first one that was selected and click on the OK button. Now we can see here, if I switch over to the Zen Center GUI, that we will begin to see some new storage repositories come into place on the destination compute cluster, which is highlighted. What actually is happening with Zen Server with its storage XenMotion is you have to, in our case for this particular type of primary storage, we need to create a new SolidFire volume per source SolidFire volume. So for example, I'll go ahead and highlight the virtual machine and switch over to its storage tab. We have 2 storage repositories here which I'm highlighting. Each of them map to its own SolidFire volume. To make storage XenMotion work, we need to create a new SolidFire volume for each of these existing SolidFire volumes that supports these virtual disks. Then we need to create a storage repository on each of those newly created SolidFire volumes, and we need to copy the contents of the virtual disk from each source storage repository to each newly created storage repository on the destination side. So to make this a little bit more easy to visualize, let me switch over to the SolidFire GUI. And we can see here, we already had root-24 and data-24 as 2 separate SolidFire volumes. If I hit the refresh button, we'll see that we actually have a new data-24 and a new root-24. So on these new SolidFire volumes, we have created brand new storage repositories. And we've made these available to the destination resource pools hosts. What then happens is the virtual disk image, for example, and I'll highlight this here, the virtual disk image that's in the storage repository that's on the selected SolidFire volume will get copied from the selected SolidFire volume, which is accessible in our source resource pool, to this one here that I'm highlighting, which has a different storage repository, it will get the contents of that virtual disk image copied to it, and the storage repository that contains that newly created virtual disk image, that storage repository is available, it's visible to both of the hosts in the destination resource pool. Same concept for the data disk. This SolidFire volume that I've highlighted contains a storage repository with our virtual disk image that represents our data disk. The contents of that virtual disk image will get copied to a new virtual disk image in a new storage repository on this SolidFire volume that I've just highlighted. So if I switch over to the volume overview tab here, we can see that we have root-24 was originally visible to our second Xen server resource pool, the one that contained only a single Xen server host. And now it has a root-24 that's visible to the first Xen server resource pool. Once the copy has completed and we're ready to cut the VM over from the source to the destination resource pool, we will see our original root-24 and data-24 will be deleted. And in their place, we will have root-24 and data-24 in the first Xen server resource pool, and those will be used by the virtual machine that was migrated from the source to the destination resource pool. So let me go ahead and hit the refresh button here, and we'll see if we're far enough along in the process that 52 and 53 have been deleted. And actually, while that's doing its thing, let me take a look at this from the Xen Center point of view. We can actually see, I'll go ahead and highlight it, that our virtual machine has been successfully migrated. And if we look down here toward the shared storage repositories, we do have a data-24. And if we look at its storage tab, there's our virtual disk. This is our data disk, and it's attached to our virtual machine. And then if we go find root-24 and look at its storage tab, we can see that its virtual disk, which is our root disk, is attached to the same virtual machine. So the process has completed and it was successful. So let's go back over to the SolidFire system, and we can see here that in fact volume 52 and 53, which were our original root and data volumes, have been deleted in favor of the ones that I'm highlighting now, which are accessible to both of the hosts in the first Xen server resource pool. If I go and take a look at the deleted SolidFire volumes, we'll go ahead and see that the ones 52 and 53 are here in the deleted state. So those were discarded after the process of storage XenMotion completed successfully. So if we switch back to CloudStack, I'm going to click on the Instances tab, and we can see here, if I click on the VM again, its name, and scroll down to the bottom, we can see that we are in fact on a different host. And if we were to go ahead and initiate the process of migrating the virtual machine, and I'll go ahead and click on the button here, we can see we actually have a couple different options just like before, but unlike before, we have two different ways of migrating this virtual machine right now. We can either simply move the virtual machine from the one Xen server host in the first resource pool to the second Xen server host in that same resource pool and not require any kind of storage migration, or we can go across resource pools and put this virtual machine back in the original resource pool that it came from, but that being cross compute cluster or cross-resource pool would require a storage migration. But I just wanted to point out that you do have those two different options. Now, this first option, when it's not across compute clusters, that has actually been supported since version 4.3 of CloudStack. And this second option, where you actually copy the contents of the virtual disk images from one resource pool to another, that is what is being newly introduced here in the 4.10 release of CloudStack. Thank you for watching.